just like the last practice quiz, write out the null hypothesis and alternate hypothesis for its researchers non-directional hypothesis test using the correct notation. Okay. Null hypothesis H0. Okay. It is mu sample mu is it's non-directional, so okay, it stays the same, which is 80, and null hypothesis is H1, and sample mean, not sample mean, wrong, population mean after the intervention or any accidents would be greater than 80 or lower than 80, or in other words, it's anything other than 80, not equal to 80. So these two. State the null and alternate hypothesis is in your own words. So, okay, any accidents we have no effects on people's cognitive functioning. Okay, so will have no effects on cognitive functioning. And an accident will have some effect on cognitive functioning. The alpha level is 0.05, and researcher is doing a non-directional hypothesis test. What are the critical value of Z? Okay, make the critical value on standard normal distribution below and shading. Okay, so alpha level is 0.05 for non-directional, means it's 1.95 on a Z. Value of Z is here, 1.96, and here minus 1.96, and the critical value Z is here and here. 3. Calculate the Z-score for the sample mean of 75. Okay. Alright, so yeah, this is 80 and this is 75, and calculate Z for that. 75 minus 80 divided by sample. Okay, sample mean, standard deviation of sample mean is okay, population size is 100, so that, and the standard deviation was, how much was that? 20. So it's okay, so it's 2 equals, okay, that's the Z value, Z score. Use your standard normal table to determine the p-value for this non-directional hypothesis test. Okay. first of all, okay, 1, 2, yeah, it's about here. It's minus 2.5 and minus 1.96, 1.96. Okay. P-value, huh? The p-value. Actually, I don't really need p-value to finish off this, problems, but because it says p-value, let's look at the p-value for that. 2.5 is 0.0062. Okay, so p-value here is 0.0062. Was it? I think it was. Yeah. So yeah, the probability is 0.0062. 2.5, and this is also 0.0062. So in other words, okay, alpha level 0.05, when the alpha level is 0.05 and p-value is 0.0062 times 2 equals 0.0124. Okay. In any case, it's less than alpha level, so reject. So p-value of 0.0124 is smaller than alpha 0.05. So okay, in other words, 75, getting 75 out of the population of mean 80 and a standard deviation of 20, possibility is too low, so we reject null hypothesis. That's what you're gonna do, but let's look at it. Maybe that's the second question. Interpret the p-value in your own words. What, didn't I just do that? Oops. Okay. So make a decision about the null hypothesis. So do you reject or fail to reject? So in this case, reject null hypothesis with the p-value of 0.0124 and alpha 0.05. State a conclusion in your own words. So conclusion is, it is highly unlikely, reject the possibility. Reject the possibility that the mean of 75 could have come from the population of 80 and the standard deviation of 20. Maybe that was some effect on cognitive function. Okay. Estimate the Cohen's defect size measure. Use the guidelines to describe the size of the effect. Okay, so we got 75, right? And population mean was 80, right? So 75 minus 80, how significant is this? And standard deviation was what was that? 20. So it's 5 minus 5 and 20 minus that minus 0.25. Okay, so D was 0.25, so it's small effect. It wasn't medium. It was not negligible effect. It was actually a small effect. Okay. So define type 1 error and type 1 2 error in your own words. I think I did already. Okay, type 1 error. Okay, it's the chance that no hypothesis, right? No effect. So no effect is actually a conservative decision. There's no effect, so you're not gonna do anything, right, about it. But you rejected it. Reject. But it was actually true. That's the type 1 error. I mean, rejecting no effect means thinking there's effect. So it's a dangerous error. Type 1 error is kind of serious error, because if you say just no error, it's not harmful. There's no harm in saying there's no effect. You're not gonna do anything. But instead rejecting it, thinking that there's the effect, that's a dangerous thing, because you're gonna start doing things with the result. You can start making drugs, for example, start giving some interventions to people and messing up people's mind or behavior or health. That could happen. Okay, type 2 error is null hypothesis. Failing to reject. In other words, keeping this. So it's kind of safe, keeping this when you should have rejected it. That's type 2 error. And it's kind of safe because you keep in that no effect conclusion, because if you think there's no effect, you're not going to do anything. You're not going to waste money on anything. You may not be making a breakthrough in research because you thought there's no effect, when there were actually, the truth was there's some effect. So that's the implication of type